The wind on Mauna Kea at 2 in the morning is a living thing, sharp and cold, slicing through your jacket like it has a grudge. The dome of the Atlas telescope yawns open to a sky so clear it feels like you could fall upward into it. Inside the control room, the night operator sips coffee gone cold hours ago, eyes fixed on a monitor that refreshes every 90 seconds. And then it happens. A single pixel shifts. Not a star, not a satellite. A smudge sliding left to right against the diamond dust of the Milky Way, moving at 58 kilometers every second. That is 210,000 kilometers an hour. Fast enough to circle Earth 5 times before you finish this sentence. The operator leans forward, heart suddenly loud in the silence. The software flags it. Unbound orbit. The coffee cup trembles in a hand that has seen 1,000 false alarms. This is no false alarm. Within minutes, the Minor Planet Electronic Circular pings astronomers from Tokyo to Tenerife. Slack channels light up like Christmas trees. Someone in Pasadena runs the numbers twice, then a third time, because the eccentricity reads 1.43. That is not an ellipse. That is a one-way ticket. By dawn on July 10th, 2025, the International Astronomical Union stamps the name. 3I/2025 A1 Atlas. The third confirmed interstellar object ever recorded. The first two were strange enough, but this one is already screaming its otherness across the void. It will swing past the sun at 1.40 astronomical units on November 29th, brush Earth at 1.86 AU on December 14th, and then vanish forever. A cosmic drive-by. A message in a bottle hurled across the gulf between stars, and we have exactly 5 months to read it before the bottle shatters into the dark. Stand outside tonight, wherever you are. Look up. That sky you have known since childhood just got stranger. Somewhere out there, a relic older than Earth is falling toward us, wrapped in a shroud of frozen breath from a star that died before our oceans existed. The James Webb Space Telescope, our golden sentinel a million miles beyond the moon, is already turning its mirror toward the intruder. What it will see is not just light. It is memory. It is chemistry. It is the diary of a world we will never visit. And you, yes, you, are alive to witness the opening of the envelope. Hit the like button if the thought makes your pulse race. Comment, "I saw the blink," so we know you are in this with us. The universe just whispered. Let us listen together. Long before Atlas, the sky had already sent us postcards from the abyss. The first arrived in October 2017, after it had already slipped past the sun and was racing outbound. Astronomers named it 1I/Oumuamua, Hawaiian for scout from the distant past. It was 400 meters of tumbling rock, shaped like a cosmic cigar, glowing reddish under reflected sunlight. No coma, no tail, just a silent spinning needle that accelerated without any visible exhaust. The physics forums exploded. Was it a hydrogen iceberg, outgassing invisibly? A shard of a shattered planet? Or, in the fevered corners of the internet, something built? Its speed was 26 kilometers per second when it left us, enough to reach Proxima Centauri in 16,000 years. It is gone now, swallowed by the Oort cloud, carrying its secrets into the dark. 2 years later, in August 2019, the second visitor crashed the party with proper cometary flair. 2I/Borisov burst into view, trailing a tail 100,000 kilometers long, glowing cyan and carbon monoxide. Ground telescopes drank in its light like wine. But the taste was wrong. The comet was drenched in CO, 3 to 10 times richer than anything born in our sun's nursery. Water vapor, the lifeblood of solar system comets, was barely a whisper. It was as if someone had baked a cake with no flour. Its velocity clocked 32 kilometers per second, and backward trajectories pointed toward Kruger 60, a pair of red dwarfs 13 light-years away. Borisov looped around the sun and departed, tail waving goodbye like a scarf in the wind. 2 visitors, 2 riddles, 2 lessons. The space between stars is not empty, and what crosses it does not play by our rules. Now, the third act arrives, and it is singing louder than both predecessors combined. 3I/Atlas is already active at 7 astronomical units, farther out than Jupiter, where solar heat is a polite suggestion rather than a command. Its hyperbolic path is steeper, its chemistry more extreme, its voice more insistent. Oumuamua taught us to look. Borisov taught us to taste. Atlas is teaching us to listen with every instrument we have ever built. The prologue is over. The curtain is rising. Share this chapter with someone who still believes the sky is familiar. Tell them the universe is about to speak in a language we have never heard. Float with me now, past the moon, past the clutter of satellites, to a place where the sun is a distant campfire and Earth a blue marble in the rearview mirror. This is Lagrange Point 2, a million miles beyond our world, where gravity balances like a tightrope walker. Here drifts the James Webb Space Telescope, its 18 golden hexagons unfolded like a mechanical sunflower, its 5-layer sunshield the size of a tennis court keeping the instruments at minus 223 degrees Celsius. On August 6, 2025, at 14:22 UTC, Webb's computers receive a command from Maryland. Slew to right ascension 18 hours 42 minutes. Declination minus 12 degrees. Lock on. Track. Do not blink. The target is a speck 19.8 magnitudes faint, 10,000 times dimmer than the human eye can resolve. It is moving 58 kilometers every second, crossing Webb's field of view in mere hours. Miss the window and the comet is gone forever. Engineers in Houston hold their breath. The telescope's fine guidance sensors nudge the mirror by 7,000ths of an arcsecond, the width of a human hair seen from 10 kilometers away. The near-infrared spectrograph opens its slit. The mid-infrared instrument unfurls its gratings. Photons that left the comet's glowing shroud 4 hours earlier begin to rain onto the detectors, each one a messenger from another star. 4.5 hours later, the data streams home at 57 gigabits, compressed into pulses of laser light bounced off relays in geosynchronous orbit. Scientists in Baltimore open the files and gasp. The image is not a blurry dot. It is a spectral tapestry stretching from 0.6 to 28.3 micrometers. Carbon dioxide blazes at 4.26 micrometers, 8 times brighter than water's timid signature at 2.7. Carbon monoxide, carbonyl sulfide, silicate dust, ice grains, all mapped in exquisite detail across a coma 150,000 kilometers wide. The nucleus hides at the heart of the glow, a dark seed no larger than a city, but its breath paints the sky in infrared fire. Webb did not just take a picture. It read the comet's diary in a language of light, older than humanity. Subscribe and tap the bell. The next chapter will make your jaw drop. Every comet we have ever loved was a water comet. Bring it close to the sun, and the ice sublimates at minus 100 degrees Celsius, exploding into vapor that drags dust into glorious tails. Halley's Comet was 80% water. Hale-Bopp glowed with water fountains. Even little 67P, visited by Rosetta, wept rivers of H2O when the sun kissed its surface. Water is the soul of cometary activity in our neighborhood. It is the reason we see them at all. And then comes 3I/Atlas, strutting into the inner solar system like it never got the memo. Its coma is a dry ice storm. Carbon dioxide dominates at a ratio of 8:1 over water vapor. 8:1. The most CO, too-rich solar system comet, Hartley 2, managed a measly 1:1. Atlas just rewrote the recipe book and burned the old one. Imagine forming in a disk so cold that the snowline for carbon dioxide lay inside the orbit where water usually freezes. That is 20 astronomical units, or more, from a dim red star, a nursery where oxygen was scarce and carbon ruled. The comet's parent system must have been a chemical factory unlike our own, cooking its planetesimals in a broth of carbon dioxide ice and organic tar. But the puzzle deepens. Why is the water so quiet? Something is keeping it locked away. Perhaps a crust of refractory organics, thick and sticky, seals the deeper layers like asphalt over a buried lake. Perhaps cosmic rays over billions of years cooked the surface, splitting water into hydrogen that fled and oxygen that bonded elsewhere. Or perhaps this comet was simply born thirsty, its water locked into minerals instead of ice from the very beginning. Look closer at the spectral maps. The carbon dioxide emission blooms from the sunward side, not in sharp jets, but in a diffuse glow, as if the entire dayside is exhaling through a porous skin. The nucleus is a sponge, letting gas seep evenly rather than erupting in tantrums. This is not a fireworks show. It is a slow, steady breath from a traveler who has forgotten what rain feels like. Comment DRYICECOMET if this flips everything you thought you knew about the sky. Comets are supposed to dance when they sing. The vapor jets that sculpt their tails also act like rocket engines, nudging the nucleus off its predicted path. Astronomers measure this as non-gravitational acceleration, a gentle push that reveals mass and activity. Borisov felt it. 67P felt it. Even tiny dust grains feel the solar wind. But 3I/Atlas? Nothing. Zero. The coma is spewing 300 kilograms of gas and dust every second, enough thrust to move a truck. And the nucleus does not budge by even a micron per second squared. It is as if the comet looked at Newton and shrugged. Estimates place the nucleus between 1.4 and 5.6 kilometers across, a dark pebble lost in its own glowing fog. Mass calculations, pieced together from outgassing rates and gravitational deflection of nearby dust, exceed 33 billion metric tons. That is denser than granite, denser than many asteroids. Something inside is anchoring it like a cosmic seawall against a hurricane. Perhaps an iron-rich core, forged near its parent star and peppered with nickel grains, now vaporizing in the sunlight. Perhaps a matrix of amorphous ice and organic polymers so tough it rivals concrete. Or perhaps the outgassing is perfectly symmetric, every puff balanced by an equal puff on the opposite side, thrust vectors canceling into stillness. Stand on the nucleus in your imagination. The surface is black and pitted, warm enough on the dayside for dry ice to hiss through cracks. The coma towers above you, a glowing ceiling 500,000 kilometers high. You fire a rocket engine, and the ground does not flinch. This is not a fragile snowball. This is a fortress that has crossed the galaxy and arrived laughing. Share this chapter with an engineer and ask them how you stop a comet from moving. Watch their eyes widen. To reach 58 kilometers per second relative to the sun, 3I/Atlas was not gently nudged. It was shot out of its cradle like a bullet from a gun. Picture a young star system, perhaps a binary pair locked in a deadly embrace. One star swells into a red giant, its outer layers sloughing off in a wind that stirs the outer disk. A rogue star, wandering the galactic outskirts, passes within a light year and yanks comets from their orbits like a cosmic magnet. Or imagine a Jupiter-mass planet migrating inward, scattering planetesimals in gravitational pinball. Whatever the catastrophe, the ejection velocity was ferocious. The comet has been coasting for 3 to 11 billion years. Older than the sun, older than Earth, older than the calm spiral arms we call home. During that immense journey, the galaxy tried to erase it. Cosmic rays, particles moving near light speed, slammed into the surface, splitting molecules and implanting helium-3. Micrometeoroids, grains of interstellar dust, sandblasted the outer tens of meters into cosmic dust. Thermal cycling from rare passages near other stars cracked the crust like freeze-thaw on a mountain, yet the comet retained its volatile heart. Carbon dioxide began sublimating at 7.2 astronomical units, water at 3.5. It arrived with fuel in the tank and stories in the ice. Trajectory analysis points back toward Sagittarius. But after billions of years, the parent star is long gone, merged into another, or exploded into a nebula we will never connect to this wanderer. Comment your favorite ejection scenario: rogue star, migrating planet, or supernova kick. The universe is a violent place, and this comet is living proof. No single eye could drink in the whole story. This was a symphony played by 47 telescopes on 7 continents and in orbit. It began with Atlas in Hawaii on July 3rd, but the prologue was written months earlier when Pan-STARRS archival images from May 15th revealed the comet already active at 8.1 AU. Hubble joined on July 21st, capturing a teardrop dust tail at 277 million miles. Gemini South and North tracked the tail's nightly ballet, watching it stretch and curl like ink in water. The Neil Gehrels Swift Observatory caught ultraviolet oxygen radicals, proof of water sublimation at 40 kilograms per second. The Very Large Telescope in Chile sniffed nickel vapor at 13.3 micrometers. And overhead, the James Webb Space Telescope painted the infrared portrait that tied it all together. Polarimetry from Gemini North revealed dust grains smaller than smoke, scattering sunlight with a negative polarization of minus 2.7% at low phase angles. Inverting at 17 degrees, a signature never seen in solar system comets. Citizen scientists on Zooniverse classified 12,000 dust particles from Hubble images. Amateur astronomers in the Atacama posted time-lapse videos of the tail's curvature under radiation pressure. Rapid communication turned target of opportunity time on professional telescopes into a global relay race. When one observatory set, another rose. When space telescopes slept, ground stations woke. This was not observation, it was communion. Like if you have ever pointed a backyard telescope at the sky and felt part of something larger. The comet was speaking, and the world was listening with every ear it had. The calendar flips to October 12th, 2025, and the solar system holds its breath. At 0347 UTC, 3IATLAS kisses its closest point to the Sun. 1.2 astronomical units, a mere 180 million kilometers of searing plasma away from the roiling furnace that powers our days. Imagine the scene. The comet, a dark, craggy nucleus no larger than a modest city, suddenly bathed in sunlight 30% stronger than it has ever known in its billion-year wanderings. The surface temperature spikes from a bone-chilling minus 180 degrees Celsius to a blistering minus 50 degrees Celsius in mere hours. Beneath that insulating crust of cosmic tar and irradiated organics, pockets of carbon dioxide ice hiss awake like ancient dragons stirring from slumber. Gas erupts in broad sunward sheets rather than pinpoint jets, painting the sky with a diffuse, ghostly halo that swells to 300,000 kilometers across, 3 times the girth of Jupiter. From Earth, the view is frustratingly veiled. The comet sits just 8 degrees from the sun's blinding limb, forcing ground-based telescopes to avert their gaze. Yet spaceborne sentinels refuse to blink. ESA's solar orbiter, skimming the solar wind at 0.8 astronomical units, records a sudden surge in neutral gas density. 3IATLAS is exhaling 2,200 kilograms of material every second, a blizzard of dust and molecules that would fill an Olympic swimming pool in under 2 minutes. The ion tail, once a slender ribbon, balloons into a luminous plasma highway, 3 million kilometers long, twisted by the sun's magnetic field into helical curls that shimmer in forbidden coronal lines. Emotional layers stack like sedimentary rock. Exhilaration at the sheer violence of the display. Anxiety over the observational blackout, and a profound sense of privilege that we, fleeting specks on a pale blue dot, are witnessing a star system's birth certificate being torched in real time. Amateur astronomers in twilight zones risk solar filters to catch the comet's sudden brightness jump from magnitude 10 to 7.5. A naked eye beacon for those who know where to look. Professional teams trigger rapid response programs. The Neil Gehrels Swift Observatory sleuths ultraviolet hydroxyl emission, confirming water production has finally spiked to 180 kilograms per second, still dwarfed by CO2, but proof that deeper reservoirs are cracking open. Every dataset arrives stamped with urgency. This is the crescendo, the moment when the comet's structural integrity is stress-tested by solar gravity and thermal shock. Will the nucleus fracture? Will hidden supervolatiles, nitrogen, methane, maybe even molecular oxygen, flash into the coma and rewrite the chemical ledger? The answers stream in terabytes of raw photons, each one a syllable in a language older than Earth. If your pulse is racing right now, channel that energy. Drop a like to honor the teams burning midnight oil across continents. Share this chapter with someone who's ever felt small beneath the night sky. Let's remind them that smallness is the gateway to wonder. And in the comments, tell me, when was the last time the universe made your heart skip a beat? October 25th, 2025. Dawns with 3IATLAS now receding at 2.2 astronomical units. Its outbound leg, a mirror image of the approach, but forever changed. The nucleus, having shed an estimated 150 million kilograms of material, equivalent to the mass of 25 Great Pyramids, emerges leaner, its surface freshly scarred by thermal fissures and sublimation pits. JWST, granted director's discretionary time, executes a daring 48-hour spectroscopic marathon on October 23rd to 24th. The new maps are breathtaking. The CO2/CO ratio has flipped. Carbon monoxide now dominates as deeper, colder layers vent into space. Water ice grains, once trapped beneath the crust, now pepper the inner coma like diamond dust, scattering sunlight into a transient anti-tail, a spine of reflective particles pointing sunward, defying intuition. Ground-based radar from Goldstone and Arecibo's successor arrays ping the nucleus, returning echoes that suggest a rotation period of 9.8 hours and a highly irregular shape. Think of a lumpy potato sculpted by 1 billion years of cosmic sandblasting. Emotional resonance deepens here. Relief that the comet survived intact. Grief that its pristine interstellar signature is now contaminated by solar processing. An exhilaration at the treasure trove of new data. Polarimetric follow-ups from the Very Large Telescope reveal the negative polarization branch has softened to negative 1.9%, implying dust grains have coagulated into larger aggregates. Cometary snowballs growing up before our eyes. Trace nickel vapor, first hinted at pre-perihelion, surges to detectable levels in optical spectra, hinting at vaporized metal droplets condensing in the cooling outflow. Astrobiologists lean in. Nickel-iron grains could act as catalytic surfaces for prebiotic chemistry, a mobile chemistry lab adrift between stars. Archival mining extends the timeline backward. Pan-STARRS images from March 2025, initially dismissed as noise, now reveal 3IATLAS at 7.8 astronomical units, already faintly active, pushing the onset of sublimation to distances where solar flux is a mere 2% of Earth's. This precocious behavior forces a rewrite of thermal models. Perhaps hypervolatile clathrates or amorphous to crystalline ice transitions lurk within. The human story weaves through every dataset. Graduate students defending theses on dust porosity, veteran astronomers tearing up at press conferences, citizen scientists contributing photometry via apps on their phones. This is science as communion, a global vigil for a departing guest. If these revelations stir something primal in you, comment with the one molecule you wish we could bottle from 3IATLAS. Hit share to keep the afterglow alive in someone else's feed. And like this video to salute the comet's resilience and ours. November 2025 arrives, and 3IATLAS fades beyond 3 astronomical units, its brightness plummeting to magnitude 16, visible only to the largest professional instruments. Yet its legacy detonates across disciplines like a supernova's aftershock. Exoplanet scientists recalibrate formation models. If carbon-rich comets like 3IATLAS are common ejecta from CO2-rich disks, then super-Earths orbiting M-dwarfs may inherit atmospheres thick with dry ice rather than water vapor, shifting the habitable zone paradigm. Astrobiologists draft white papers proposing that interstellar comets are panspermia expressways, ferrying resilient organics across galactic distances. Lab experiments begin irradiating analog ices with the exact cosmic ray spectrum 3IATLAS endured. Planetary dynamicists simulate ejection mechanisms, close stellar flybys, planet-planet scattering, even black hole kicks, concluding that 1 in 10 to the 5th power planetesimals from typical systems may achieve interstellar status, implying the Milky Way hosts billions of such wanderers. Emotionally, the farewell is bittersweet. We will never see 3IATLAS again. By 2030, it will be 100 AU out. By 2100, 1,000. By the year 1 million, a distant memory lost among the stars. Yet its data, terabytes of spectra, images, and light curves, will be mined for centuries. Machine learning algorithms trained on its polarimetric quirks will flag future interlopers years before human eyes notice. Space mission architects sketch interceptors, nuclear electric probes that could rendezvous with the next 3I-like visitor in the 2040s, drilling into pristine subsurface ice untouched by sunlight. Children born in 2025 will grow up knowing that the chemistry of life's building blocks is not unique to the sun, but scattered galaxy-wide, emboldening the search for biosignatures on exoplanet atmospheres. The final emotional crescendo is hope, raw, defiant, universal. Every spectrum line from 3IATLAS is a love letter from the deep past, proof that the universe is not a cold void, but a tapestry woven with stories waiting to be read. As the comet dissolves into the Oort cloud's outer fringe, its molecules will diffuse, some perhaps captured by future solar system bodies, a microscopic diaspora of alien heritage. We stand at the threshold of an era where interstellar objects are not anomalies, but expected guests, each arrival a chance to touch another star. So here's the ultimate call to action. Carry this wonder forward. Teach a child to spot the comet's fading glow in a backyard telescope. Volunteer for citizen science photometry. Fund the next generation of space telescopes. In the comments below, pledge one way you'll keep the flame of curiosity alive. Like this video, not for algorithms, but for the astronomers who will watch it at 3 a.m. during their observing runs. Share it across borders, languages, and generations. Because the story of 3IATLAS is now part of humanity's shared mythos. And when you look up tonight, whisper thanks to a small, dark world racing away at 200,000 kilometers per hour, carrying a piece of our awe into the infinite. The universe is listening.